Good morning. Welcome to Currents Chem World. In this video, let us learn what is called over voltage or over potential. Why does it occur? What are the reasons for over voltage? How it is determined in this video. Okay, over potential is denoted by eta. It is represented by eta. It is defined as the difference between the actual observed potential at which the electrode process takes place and the reversible or theoretical value of that process. Okay, so the over voltage equal to, it is mathematically expressed as observed potential, actual decomposition potential minus deposition potential, or we can say at the potential it deposits. Okay, so observed potential minus theoretical value, where ED, observed potential, is also called deposition potential or decomposition potential. If it is a gas, it is decomposition. If it is a metal ion, it is called deposition potential. Okay, so it is the equal to ED minus ER, where ER is the reversible potential value. Okay, for example, what is over voltage? Let us understand in a simple layman. You are going in a Ola auto or Ola car, okay, Ola taxi. Then the driver will ask you, sir, give me some extra, that is above meter. Okay, they will say above meter. That is over voltage. It is similar to over voltage. Okay, it won't actually, for example, it should deposit, for example, silver should deposit at particular potential value. Okay, 1 point something, let us now it won't deposit at that potential unless you give some over 1.3, 1.5, because it is because of back EMF. Okay, it's because of back EMF. We'll see what is the reason for over voltage. This is the expression for over voltage. Okay, what are the reasons for over voltage? Why does it occur actually? It is mainly due to, observed due to back EMF or called polarization EMF. We will study. For example, when one normal H2SO4 is electrolyzed, when you will see in the electrolytic cell setup, hydrogen evolution occur at the cathode. Oxygen evolution, oxygen is evolved at the anode. So in other words, it is defined as the difference between the potential of the electrode at which the gas evolution takes place is actually observed and the reversible theoretical value potential for the same solution. Okay, this reversible value is obtained from the Nernst cell EMF. Okay, we will further see, we will further understand. Okay, let us give explanation to over voltage, and let us consider an electrolytic cell. The experimental setup is as follows. This is the experimental setup for the determination or for the measurement of over voltage. Okay, so determination of over voltage. In this setup, external source of EMF, a battery, is used to apply EMF to the electrolytic cell. Using this battery, a potential is applied and a variable resistor is used to vary the applied potential. To vary the applied potential. Okay. Voltmeter, ammeter are used to measure current and voltage passing through the electrolytic cell. Okay, let us consider in this there are two electrodes and a stirrer. Okay, and one normal H2SO4 is the electrolyte. Let us take one normal aqueous solution is electrolyzed using two platinum electrodes, cathode and anode, at 25 degree Celsius. See, at cathode reduction takes place. Okay, hydrogen is evolved. At anode, oxygen is evolved. Okay, so in the beginning, as you see, H plus ion is reduced. Okay, after some time, you see, hydrogen gas is evolved. So the presence of products of electrolysis results in back EMF. It will form galvanic cell. For example, hydrogen, you have hydrogen ion evolved, adsorbed on the electrode surface, H plus ion is there. So instead of electrolytic cell, it will form galvanic cell, that is H2 hydrogen gas electrode. It becomes hydrogen gas electrode. Therefore, this is cathode. It will act as anode. Galvanic in electrolytic cell, it is cathode. In galvanic cell, okay, hydrogen gas electrode it will form. Therefore, due to the formation of the products of hydrogen gas and oxygen gas, results in back EMF, reverse back EMF due to polarization. This back EMF is also called a polarization EMF. So in the electrolytic cell, as I said, at cathode hydrogen gas is released. These are in the diagram. Okay, at anode, OH minus ion is oxidized to give oxygen gas. Okay, so 2 electron. At cathode, reduction takes place. At anode, oxidation takes place. Okay, so H2 gas is released at the cathode. Now cathode, H2 plus H plus ion will form a hydrogen gas electrode. So it will give opposite EMF to the potential you apply. You apply one potential, but because of the formation of products, there will be opposition, back EMF. Okay, so the net reaction is shown here. On adding the 1 and 2, you will get this. Okay, the over potential is equal to ED minus ER. In the first slide we have seen. So what is the decomposition potential? It is nothing but deposition potential or decomposition potential, the potential at which the metal ion is deposited, or the potential at which the hydrogen oxygen gas are evolved. Okay, for the above electrolytic cell, as you increase the potential at which, this is the decomposition potential. Okay, this is the decomposition potential, 1.7 volt. At this potential, evolution of hydrogen and oxygen gas take place. This potential was found to be decomposition, because water is decomposed into hydrogen and oxygen gas. Okay, so this potential is called decomposition potential. This is for electrolysis of sulfuric acid. If you take silver nitrate, then deposition potential. It is called deposition potential. Okay, and this is called this is also called the deposition potential, or the experimental value of the potential, or observed value of the potential, or actual value of the potential. Okay. Okay, as I said earlier, see, hydrogen gas is evolved. So galvanic, in the electrolytic cell, galvanic cell was formed. Galvanic cell, that is hydrogen gas electrode. The setup was similar to hydrogen gas electrode. So since galvanic cell was formed because of the products hydrogen gas electrode, oxygen gas electrode formed. So let us set up the hydrogen, this is hydrogen gas electrode, we have oxygen gas electrode, let us connect, okay, hydrogen gas electrode, and you have, I have not shown here, let us take oxygen gas electrode in one normal sulfuric acid solution. The following reaction takes place at the respective electrodes. Here you see H2 in the cathode, in the electrolytic cell cathode. Now in the galvanic cell it becomes anode. The same in the electrolytic cell cathode, where H2 gas is formed, the gas H2 gas in reverse it forms an anode. So that is the reverse potential. Okay, now understand. So and similarly oxygen gas is evolved. Now the oxygen gas evolved is reduced to give OH minus ion. So the reversible theoretical e.m.f of the above cell is given by the above Nernst equation. Using Nernst equation, since it is a galvanic cell, the Nernst equation can be applied to calculate the reversible e.m.f of the hydrogen gas electrode, oxygen gas electrode. Okay. Let us calculate the over potential of this one normal H2SO4 electrolytic solution. Okay. So ER equal to, according to Nernst equation, the reversible potential is equal to E cathode minus E anode for galvanic cell. Okay. This is electrolytic cell, this is galvanic cell. Okay, E cathode minus E cathode minus E anode. Okay, here reduction takes place. In the galvanic cell, reduction takes place. In the electrolytic cell, we have already the opposite. The reactions are opposite. In the galvanic cell, the reactions are opposite from electrolytic cell. Okay, so 1.23. This is the standard e.m.f of oxygen gas electrode, 1.23, and for hydrogen electrode it is a standard electrode, it is 0.00 volt, you know that. So 1.23. Let us substitute in the over voltage expression eta equal to Ed minus Er, deposition potential we have already determined 1.7 volt, minus this reversible e.m.f obtained by using Nernst equation 1.23. Therefore, the 0.47 volt, we need to apply this much extra to decompose hydrogen water in the one normal H2SO4. This excess potential is termed as over voltage or over potential. So where Ed equal to decomposition potential or deposition potential in the case of metals of the electrolyte, Er reversible potential of the cell obtained by using Nernst equation. Thank you for watching. Please subscribe and share. Thank you very much again.